Hello, I'm Mr. Fedor, and this is for elementary statistics at Tunxis. We have just finished probability. We just had our second test on probability, and now we are going to be moving into binomial probabilities. With binomial probabilities, we are talking about experiments that have two outcomes, okay? Success and failure. The variable that we're going to use for success is P, and the variable that we are going to use for failure is Q. So if you think back to when we talked about flipping a coin, okay, if we were going to flip a coin, our success rate for flipping heads would be 50%. Our failure rate would also be 50%. Okay. The nice thing about binomial probabilities is that we can use a table to find these probabilities. So for example, if I said that we were going to flip a coin 3 times, okay, our sample size is going to be 3. And the question that we could ask is, what is the probability that we are going to get exactly 1 head? Okay. In the past, we had to use a tree diagram to figure out this probability. Now with our probability table, okay, which was a table that you were given in class, okay, which we will also be showing you. As long as we know our 3 pieces, as long as we know what our n is, what our x is, and what our probability of success is, if we look up those 3 values on our table, okay, what we are going to find is the actual probability. So looking at my table, a probability of 50%, a sample size of 3, and x being 1, the probability list there is 0.375. Okay. If you think about that probability, okay, that means 3 out of 8. When we did our tree diagram, there were 3 possibilities where you would have heads coming up once. The probability of having 0 heads, or tails, 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 if you look that up on the table, would be 0.125, or 1/8. Okay. So the nice thing about the binomial distribution is that we are going to be able to use our table all the time to find these probabilities. Okay. So a little bit more about the binomial distribution. Okay. The trials are independent. So again, if the trials are independent, that means that the probability is going to stay the same. Okay. The probability will not change. Okay, P and Q will be those same amounts throughout the experiment. Okay, and again, we're doing this with 2 outcomes. So other ideas here, if we were talking about defective, non-defective items, okay, if we're talking about true or false, if we're talking about 2 items, Coke versus Pepsi, anything that we can put into 2 outcomes is a binomial experiment. Okay, the second thing that we want to talk about with the binomial is, how do we find the mean? Okay, how do we find our center? And how do we find our spread? So when we talk about the mean, okay, again, think about it in common sense terms. If I said to you that we were going to flip a coin 10 times, so our sample size was 10, okay, how many times would we get heads? Well, we know the probability of getting heads is 50%. So half the time we should come up with heads. Our sample size was 10, our probability is 50%, so our mean is 5. Okay? So our formula for the mean will always be n times p, okay, no matter what. To find the standard deviation, it's going to be n times p times q, the square root. So again, if I take half of 10, that's 5. If I take half of 5, that is 2.5. Okay, and if we take the square root of 2.5, okay, in our calculator, that is going to give us a standard deviation of 1.6. Okay, so again, with any distribution, we want to know what's our center, what is our spread. To give you another example with that, okay, let's say that we knew the sample size of babies, we were looking at 2,000 babies. Okay, and the probability that a baby is going to be a twin is a 3% chance. Okay. So again, to find our mean, we're going to multiply 3% of 2,000. Okay, and 3% of 2,000 would be 60. To find our standard deviation, if success is defined as 3%, okay, probability of having a baby, then the probability of a baby not being a twin would be 97%. Okay. And again, if we do that in our calculator, 2,000 times 3% times 97%, 58.2 would be the variance. And if we take the square root of 58.2, 7.6 will be our standard deviation. So again, center and spread is what we're always interested in statistics. So if we find the center and the spread, okay, we can get an idea of what our distribution is going to look like. Okay. In the next video, what we'll be looking at closer is finding actual probabilities of a binomial distribution.